In this unit, we're going to be looking at the periodic table, and we're going to start off with a little history about the periodic table and how it kind of came into what we currently have. Uh, first of First of all, way back in 1750, we only had 17 elements identified. We are constantly putting new ones on the periodic table as new elements are discovered. And most of those 17 elements were metals, so things that they could find as they were maybe digging for gold, gold being a metal, aluminum, so on. In 1789, Lavoisier, he classified elements into categories. So he had metals, nonmetals, and then he had gases and what he considered earth. In 1860, we have a scientist named Mendeleev, and he is definitely one that you need to be familiar with. He worked on a new way of organizing elements, and he organized them according to their masses. And instead of just kind of listing off all of the elements, he kind of separated them into columns based on common properties. So it looks like this that you see here on your screen, this picture. So he just had these group numbers across the top, and he just put the symbols for the elements, and he based it again off their common properties. So the arrangement of the elements, if they're in this same group, they have similar characteristics, just like in a family, you would have similar characteristics. And the properties repeated from row to row. So from row 1 to row 2, the properties were similar from row 2 to row 3, and so on. Now, our current periodic table is an arrangement of elements, and we do have them in columns based on their set of properties still. So each column has some similar characteristics. So they're not identical by any means, but they do have some properties that are the same. Now, Mendeleev also had some empty spaces in that periodic table you saw just a moment ago, and he left those spaces in the table for elements that hadn't been discovered yet. And not only that, but he then made predictions on what those unknown elements would be like. So based on the family they were in and where it was at on, the empty box was, because if you notice the masses normally increased as you went down as well, he was able to make some predictions. And should his periodic table be well designed, then his predictions should come true. And as time went on and more elements were discovered, that's exactly what happened. There was a very close match between Mendeleev's predictions and the actual properties of the elements once they were discovered. The current periodic table, we have a periodic law, and this means that the elements are arranged by increasing atomic number. So we've talked about that from the last chapter, how they're arranged by atomic number. And we also have what we call periods. These are the rows going from left to right. So if you're looking at a periodic table, you're looking here, okay, the ones going left to right. There are 7 total periods in our current periodic table. And the number of elements per period goes up as you move down the table, and that's because of the electron cloud diagram and the fact that there are more orbitals, and the orbitals vary as you go up to higher energy levels or higher periods. The other part to our periodic table are the families or the groups, and again, if you're looking at a periodic table now, we're talking about the columns that are going up and down. So they're called groups or families, and they get that name because if they're within the same group or family, then they have similar characteristics or similar properties. One of the characteristics that they all have in common if they're within the same family is that they have a similar electron configuration. Electron configurations are something that we will talk a little bit more about when we get into our next unit about how elements bond together. Now, the actual definition of periodic law is that patterns of properties repeat. So again, as you go from period 1 to period 2, you're also within the same family. So you're going from here to here, down a family to the next period below it, then your properties, the properties are repeating for those elements. And we've already mentioned the atomic mass. The atomic mass depends on the isotopes of the elements, and again, this is the periodic table. You see the mass on the periodic table. Normally they all have decimals, and that's because, again, it's an average. So an atomic mass unit, we abbreviate AMU, and it's actually based off of carbon. So it's 1/12 the mass of carbon, which makes it 1, because carbon's like 12.0. So we have 1 atomic mass unit. And just know that atomic masses, these are the averages that you see on the periodic table, and the averages come from the isotopes. You take the high, the low, all the masses, and you average them together.